Okay, today we're going to look at question 3 from the 2010 free response exam. So this is called Trail. It's pretty straightforward, so let's get right to it. Okay, so first of all, you're going to need the files. So please go on to my course website. I've provided a link in the description. And you're going to need this CSA 2010 PDF, and then you're going to need question 3, trail.zip. So go ahead and download the two files. And here's the PDF. So we're going to look at question 3, and this has to do with hiking trail, and we're going to be given an array with some values in it. So here's a representation of that array. So just make sure you read through this question and that you understand it. So I'm going to go ahead and do the code solution for this. So we go ahead and just scroll down to question A. All right, what do we need to do here? We need to figure out this method called isLevelTrailSegment. So essentially we're given two markers, right? A starting marker and an ending marker. And what we need to do is figure out, what the maximum elevation is between those two markers, and then, we also need to find out the minimum. Figure out those two values, and then just take the difference. And, if that difference happens to be less than or equal to 10, then that trail is level, so we return a true. Otherwise, we return a false. Okay, so let's get to the code. So I've got my BlueJ project folder here. I've opened up the file trail. So let me go ahead and write the code here in this method isLevelTrailSegment. So for this to work and compile, I do have to get rid of this little error here. So I just need to do return false in the isDifficult one. So we'll get to that part B later. All right, so now we got to figure out isLevelTrailSegment. So first thing we got to do is make two variables. So I think I'll call them, right, this actually returns a Boolean. So let me just make a result variable. Boolean result equal to false. Okay, so now I need to have two variables, one for the maximum and one for the minimum. So I think I'll call it largest. And I need to figure out a proper value for this. I could put a 0 and that would be fine. One of the things I like to do is just to set it to the first value of the array. So the array is called markers. So it's fine for me to just do this, markers. And then the first value that we're going to look at is the start value. So I'm going to put start here. I mean, I could put a 0 there and be fine. The trouble comes when we look at the smallest. So what would happen if you do this? And smallest, right? If I put a 0 there, then nothing will beat it. I mean, it's always going to be a 0. So that's why it's a good idea here as well. Just put in the first element from that array, start, and then you won't run into that problem. So, it'll go through and it'll actually give you the minimum value in that array. Okay, so the next step is I'm going to have to loop across that array called markers. So let me go ahead and do that. For int I get. So you may be tempted to do this. I get 0, I less than markers, but length, I plus plus. Okay, but you got to read the question carefully. So it's not starting from 0. It's actually starting from this index here called start, and you're ending at this index here called end. There's another wrinkle too. Okay, so start, then I just say, okay, well, just, begin at start, begin at end. It's subtle, but there's also a problem here as well, because this begins at start, but in the question, they do specify they want you to be inclusive of end. It's actually less than or equal to end. Okay, so I've got my loop all set up, and it looks fine. So the next thing I need to do is I just need to look at a marker and say, okay, well, if it's bigger than the largest value, that becomes my new largest value. So if markers I, that's bigger than largest, so that just becomes my new largest value. So I can just do this, largest, that becomes that array element. And then I just do the same thing for smallest, right? So if markers I is less than smallest, so that becomes my new smallest. So, smallest gets markers I. Okay, so once we're done with that loop, we're going to have the two values from that array, you know, the biggest value and the smallest value. So what do we need to do now? We need to go ahead and say, all right, well, if the difference is less than or equal to 10, then, you know, we return a true, otherwise we return a false. So let me go ahead and put that in the result variable that I made. So just say result gets, and then I just take the difference. So, you know, largest minus smallest. Okay, so if that's greater than or equal, sorry, less than or equal to 10, so then we know we have a level trail. So take the difference, find out if it's less or equal to 10. If it is, then it's level. So then we return true. So I'm just going to return result, and then that should be fine. All right, so let me go ahead and compile. So I'm going to hit compile here. Let me go ahead and run this. Level trail should be true, true. Level trail should be false, false. Okay, so that seems fine to me. It seems like it satisfies those two conditions. Let's go on to part B. So with part B, we have to do this method called isDifficult. So it's kind of in the same theme. You know, we're looping across the array. However, here we need to figure out if that trail is difficult. So we need to look at the changes in elevation. If we have four changes that are 30 meters or more, up or down, so positive or negative, then, you know, we return true. Yes, it is difficult. Otherwise, we return false. Okay, so let's go ahead and solve this. So it's going to be kind of similar. So I'm going to need to do, let's see, return to Boolean. So let me make a result value. So Boolean result, set that equal to false. And then I'm going to go ahead and make a variable. So let me call it change. Int changes 0. That sounds fine. Now I need to loop across. So let me go ahead and just loop across the whole thing. So for int, I get 0, I less than markers length I plus plus. Now here's where there's a little trick, because, you know, essentially what you're doing is you need to look at, you know, the element corresponding to index I, but then you need to look at the one beside it, the element corresponding to index I plus 1. So since you're doing that, you're going to run into a small problem, because once you get to the end, you know, if I is 12, then you're also going to look at I plus 1, which is 13. If you do that, you actually get an index out of bounds error. So you want to prevent that. You actually don't want to go from, you know, 0 to 12. You actually want to go from 0 to 11, right? Because when I is 11, I plus 1 is going to be 12, and that's essentially where you want to stop. So instead of saying, okay, start at 0 and go, you know, up to, but not including markers that length, you actually want to go one shorter than that. And that will prevent this index out of bounds error. Okay, so now what I want to do, I want to say, okay, take, you know, the element at index I, subtract the element at index I minus 1, or I plus 1, and then see if that's greater than or equal to 30, then, you know, you have a big difference. So it's this. So markers I, then I subtract off markers I plus 1, right? So you take that difference there, right? If it's greater than or equal to 30, then, you know, you have something there that's pretty substantial. So you just say changes plus. Now, it's not quite right, because if you think about it, we've got positive differences being taken into account. However, some of them are negative. So, you know, we want the magnitude. And in order to do that, we actually have to use something called the absolute value. So here, you know, 50 works, minus 45, well, that's not going to show up because it's a minus value. So what we want is 45. Okay, so we need to take the absolute value rather than just, you know, one subtracting the other. So that's pretty easy to do. You just say, okay, well, math.abs, and that will give me the absolute value. Okay, so last thing is, you need to say, okay, if the number of changes is greater than or equal to 3, then we know we have a difficult mountain there. Otherwise, we don't. So let me just put that in results and say, all right, well, if changes greater than or equal to 3, then we know that it's a difficult mountain, so therefore we must return true, otherwise it will return false. So just return result. Okay, so let me go ahead, compile and run and see if that works. So go here, hit compile. Let's see what this gives us. Difficult trail should be true, and yes, it is true. So that seems fine. Let me go ahead and run tests. And it seems like all the tests seem to work out. So that tells me my program is right. Okay, so that's it for this. So I can say that the question 3 trail is complete. Okay, thanks for watching. Bye-bye.